Alright, this is section 3.1 in Advanced Geometry. Today we talk about some parallel lines. What we did before was on a graph, right? On the graph, parallel lines have the same slope. That's how we can tell they are parallel. But not in a graph. Here in a picture, parallel lines are two coplanar lines that do not intersect. The magic word is coplanar. They have to be in the same plane. And we'll see what happens if they're not in the same plane here in a second. But two coplanar lines that do not intersect are called parallel lines. And we have some symbols like these two backslashes right here in a row means parallel. Just like last time we learned upside down, capital T meant perpendicular. These are the symbols for parallel. And then if you had a picture, like here I've got two green lines, line A and line B. If they were parallel to each other in a picture, they'd have to be marked with these arrows. Just like segments the same length have tick marks, and angles that are the same measure have arc marks, parallel lines have arrows. So instead of writing out like an entire English sentence that says line A is parallel to line B, we simply write that just like this in mathematics: line A is parallel to line B. So parallel lines, they got to be in the same plane, because if they're not in the same plane, those lines that don't intersect and are not coplanar are called skew lines. Skew lines, lines that do not intersect and are not coplanar. So the best way to give this example is with a three-dimensional shape, and the one you're very familiar with is the cube. So I'm a highlighter guy. If you got highlighters, you're going to want to need them here in about 5 minutes. But check out this segment right here, segment AB and segment DC. Those two segments do not intersect, and they're in the same plane, right? They're in this green plane right here. Those are what we call parallel segments, right? You know, parallel lines, parallel segments, all good in the neighborhood. But what if I pick segment AB and segment HG? Let me use red. These two guys are also parallel to each other because I can draw a plane that fits in them. Whoa, that's not very cool. How are we supposed to know what parallel is, you know? Here's a real easy way to tell. Parallel segments in our pictures, parallel lines, they do not touch each other, and they're going the same direction. Don't you see how these guys are going the same direction? So another one that would be parallel would be segment EF. These four guys right here are all parallel to each other because it's possible to draw them in the same plane. Now if I pick these two, right, these two definitely do not touch. And since they're not going the same direction and they're not in the same plane, those are what we call skew lines, right? So skew lines don't touch and are going different directions. Different directions. And then obviously parallel planes are planes that do not intersect. So if I picked this plane up here, right, refresh our memory on how to name a plane. Yes, you do need the word plane. And then you pick any three non-collinear points in that plane. You have four to choose from, so we could call it like plane ABC. And then the plane that's parallel to that, there's only one in this picture, right? That would be this plane down here. Those two definitely do not intersect. So that would be plane EFG or whatever. Any three of the letters that are in there, they just can't be on a straight line. They can't be collinear. So here are some practice problems, right? It says, name all planes parallel to plane ABD. I'm a highlighter guy. You don't necessarily have to highlight this first thing. It's pretty easy to see, but I'm a highlighter guy. I'm going to show you stuff. Here's plane ABD, right? A, B, and D on there. They want all planes parallel to it, so that means the planes that don't touch it, and we only got one choice here. Every other plane touches it, so these two planes are parallel planes. Let me name this guy then. We'll call it plane, and then pick any of these letters right here. Plane EFG would be fine. You need three non-collinear points in there. Then here's where the highlighters come in. All segments parallel to segment CG. I like to find segment CG and highlight it. Right? So segment CG. Remember, parallel means they don't touch each other, but they have to be going the same direction. So when you think about this bad boy, right? It doesn't touch it, go in the same direction. That is segment DH. Don't forget the segment bar. You could also call it segment HD, no big deal. And this guy is also going the same direction, and it doesn't touch it, so That's segment AE. And we have another one. We've got segment BF. Right, so I kind of call these the up and downers because they're going up and down in the picture, right? All of those puppies are parallel to each other. Don't forget your segment bar. Then all segments skew to segment EH. Grab a different colored highlighter, right? And you're like, oh, here's segment EH. I want all the segments that are skewed to it. So you got some choices of how you could figure this out. You could find all the ones that are skewed, just like the question asked, or you can kind of figure out all the ones that don't work, you know? And you can say right now that this guy isn't skewed to it because it touches it. This guy isn't skewed to it because it touches it. So let me use a different color. Let's do blue here. So these don't work because they intersect, right? The blue one and the red one intersect. And then you could say this one doesn't work because it's parallel to it, right? It's going the same direction. And this one doesn't work because it's parallel to it. And this one doesn't work because it's parallel to it. So I just found all the ones that don't work. Well, what about this one? That touches segment EH, so that doesn't work. And this one touches segment EH, so that doesn't work. So let's see if we can find all the ones skewed to it. This guy right here, segment AB, definitely doesn't touch segment EH, and it's not going the same direction, so it's skew. And then what do you think about segment CD right there? Segment CD doesn't touch it and is not going the same direction. Segment CG does not touch segment EH and is not going the same directions, or GC, whatever, you know. And segment BF. And then they also have this goofy one in the picture here, this segment BD. Since they drew it, we'll put it. Right? So those are all letter segments that are skewed to that bad boy. So let's try again. All segments parallel to segment NU. Highlight segment NU. Oh, that's an up and downer. So all the other up and downers should be parallel to it. So that's right there. They're going the same direction and they don't touch it. So segment OT, segment PS, segment MR. All segments that intersect segment MP. So let me find segment MP. And let's just find one to start with. This segment MR definitely intersects it, right? And it's pretty obvious segment MR intersects segment MP. The question is, where do they intersect at? Don't they intersect at point M? So any segment that I could actually highlight that's got M for an endpoint should intersect segment MP because they'd intersect at M. So I think segment MS and segment MN, right? They all have M for an endpoint, so segment MS and segment MN would be good. Those are all the segments, all the segments that have M for an endpoint. Well, since we're trying to intersect segment MP, don't forget about P. Anything that touches point P should be good, so segment PO sure does. Segment PS sure does. So PS. And looks like we are done with that. All segments skew to segment PS, so I have the luxury of being able to erase my highlighters, and you don't have that luxury. But let's see here, segment PS got to be skewed to it. So guys that are going different directions and not touching it. So what do you think about? Definitely skew. Right, so let me use my pen. Segment MN and segment NO go in a different direction, not touching it, so that's good. Segment OT, nope, that'd be going the same direction. That's parallel. This would touch it, this would touch it. Segment RU would be good. Segment UT would be fine. Is there anything else, right? So let's see if there's anything else. This is going the same direction. That's parallel. That doesn't count. Parallel doesn't count. This actually touches segment PS. Doesn't count. Touches segment PS. Doesn't count. Touches segment PS. Touches it, and that's a parallel to it. So looks like we found them all the ones that are skew. So it's not a hard concept. It's just very visually challenging, right? So Uh, Try to highlight, like I said, I'm not going to grade your highlighters. I don't care if you highlight something that wasn't supposed to be highlighted, like, oh, I didn't want to highlight that this color, so that's no big deal. I'll grade your answer right here. So highlight, I think it's a good idea. And then on numbers 4 through 7 here, I just want to do number 5, right? So it says, let's name all the planes that intersect plane MHE. Well, here's M, here's H, here's E, here's plane MHE right here, this entire plane. We want to name all the planes that intersect it. That's actually pretty easy to figure out how many answers you need. Since plane MHE is a quadrilateral, there should be 4 other guys that touch it, one on each side. Doesn't this plane right here touch that puppy? So we'll name this red plane. That'd be plane, and then pick 3 letters, MHO. It doesn't really matter. And then find another plane that touches it. That guy way over there, plane NEX would be fine. Any 3 letters that are in that plane that don't line up. And then there should be 2 more, so this front guy right here touches it. Plane HEX. And then plane, the back guy, plane MNQ. So that was skew and parallel planes and all that cool stuff. Highlighters really, really, really help. I guess, and your homework will be on paper, so that way you can highlight, because that'd be very difficult to do on the computer screen. So now we get into the big meat and potatoes of what geometry is all about, recognizing types of angles. Okay, so here's the new picture, right? But it should seem pretty familiar if I was to cover up this stuff down here. This is our old picture that we've been doing for a couple chapters now. And we should know some types of angles in this picture already. We should know about vertical angles in linear pairs. Aren't angles 1 and 3, which are right across from each other, vertical angles? And hopefully remember that vertical angles are congruent, and angles 2 and 4 are also vertical angles. And then angles like 1 and 2 that touch each other and form a line, those are a linear pair. Well, we got a whole nother set of angles down here, right? I kind of call this like 2 houses here. We got upstairs and downstairs. And let's just kind of start by defining our words here. A transversal is a line that cuts through 2 other coplanar lines. So please define these words. If you need to pause the video to actually write them down, please do that, but I'd like to just kind of keep moving. A line that cuts through 2 other coplanar lines. So check me out here. I got a blue line, I got a red line, and I got a green line. And the transversal is the blue one, line T. It cuts through those 2 other lines, and it formed 8 different angles when it did that. Well, there's many types of angles in this picture. We already know about vertical angles and linear pair. Here's what corresponding angles are. Corresponding angles are angles in the same position with respect to the transversal. Like I said, jot that down. Angles in the same position with respect to the transversal. So, let me show you my method. Remember, the blue line here is the transversal. If we just kind of pick on one of these houses, if we pick on upstairs, let's pick on angle 1 right here. Let's find angle 1's location in relation to the transversal. Isn't angle 1 to the left of the transversal, right? It's on the left side. It is also above the green the green line that belongs in its house, right? So angle 1 is to the left and above. We just want to go downstairs here and figure out which angle is also to the left of the transversal but above its line, and that would be angle 5. Angle 5 and angle 1 are what we call corresponding angles. They are in the same position with respect to the transversal. Also, if you look at like angle 4 right here, is an angle 4 to the left and below its line? It corresponds with angle 8. They are corresponding angles. And then angle 2 is to the right and above. It corresponds with angle 6. And finally, angle 3 and angle 7 are also corresponding angles. Right? They're in the same position with respect to the transversal. And if we would just stop there and never learn any other types of angles, it really wouldn't be that complicated. It's like, oh yeah, those are corresponding angles. But we have a whole other types of angles. Another type is called alternate interior angles. Angles that are on alternate sides of the transversal, but between the two lines. So please take a moment to jot that definition down. And now here, note the transversal is blue, and I just highlighted the other lines red. I could care less about telling them apart. But I want angles on alternate sides of the transversal. That means if I pick one angle on the left, the other one's going to be on the right, right, on alternate sides of the transversal, but between the two other lines. That's why they're called interior. And as you can see, if I shade this, all this green stuff, that's not between the two red lines right there. That's the exterior, right? We don't care about that. We care about the interior, all of this stuff between the two lines. So let's find a pair of alternate interior angles. Let's pick an angle to start with, angle 3. Right, you got to pick one to start with. Now, you know that 1, 2, 7, and 8 are out because they're on the exterior. We only have choices between 4, 5, and 6. Out of these three choices, 4, 5, and 6, we can eliminate 6 from it being its alternate interior angle for the simple fact that 6 is not on the alternate side of the transversal. Since 3 is on the right, its alternate interior angle has to be on the left. Right? So 6 was not a choice. So we're down to 4 or 5. And the question is, which one of those is it? Well, it can't be 4 either. And the reason why it can't be 4 is because angles 3 and angle 4 are what we call a linear pair. Right? They're already a type of angles we knew about. So you can't be like a linear pair and alternate interior angles at the same time. You just can't be two different things. So angle 3 and angle 5 are alternate interior angles. They are on alternate sides of the transversal, and they are between the two lines. And you can also see that if I go back, that angle 4 and angle 6 is also a pair of alternate interior angles. They are between the two lines and on alternate sides of the transversal. And they're not a linear pair, excuse me. So alternate interior angles. And then finally, the consecutive interior angles are angles on the same side of the transversal between the two other lines. On the same side between the two other lines. So again, if we pick an angle, they have to be interior, right? So we only got between 3, 4, 5, and 6, those angles right there. If I pick on angle 3, since they have to be between the two lines right here, and on the same side, you only got one choice. It's got to be angle 6, right? So angle 3 and angle 6 are consecutive interior angles. You might accidentally hear me call them same side interior angles because that's what our book last year called them, was same side interior, but consecutive interior angles. They're on the same side of the transversal in between. So 4 and 5 are also consecutive interior angles. So yay! Now, here's all the choices. It says classify these type of angles as either alternate interior angles, corresponding angles, vertical angles, linear pair, or consecutive interior angles. So here's the picture they want us to use. Let's name these angles. Angle 1 and angle 3. Right, so I'm going to circle them and then erase them since I'm using a pencil and you're using a pencil. Just finding the angles in the picture. What kind of angles are those? Those are vertical angles because they're right across from each other. So we definitely knew about vertical angles. Now, in part B, angle 4 and angle 8. Those are one of them new type. Since angle 4 is to the left of the transversal and below its line, and angle 8 is to the left and below, those are what we call corresponding angles. And we'll spell the whole thing out. Corresponding angles. You can use the angle symbol. That's fine. Then angles 4 and angles 5. So let me get my eraser. Angle 4 and angle 5. They are between these two lines, so they are interior, and they're on the same side, so those are consecutive interior angles. And what I'd like you to do is to finish this set of problems. Do D, E, F, G, and H. Why don't you pause the video and give those a finish, and then we'll see if you got them right. So give her a pause. So hopefully on D you had alternate interior angles for 4 and 6, and 7 and 8. They are a linear pair right there. They're right next to each other, forming a line. and 7 and 3 are corresponding angles, and 4 and 6 were alternate interior angles, and 3 and 6 were consecutive interior angles. Now I know this is kind of weird over a video, because if you had a question, please come see me if you had a question, because it's totally okay. There was lots of questions in class. It's like, why is this? Why isn't it this? Why isn't it that? So if you're not sure about this, you gotta come see me, because of the fact that this is a huge part of what we're going to do for the rest of the year, right? What kind of angles are these? What kind of angles? So, awesome. Now, here's a big boy. Here's a theorem right here that says if two lines are parallel, then corresponding angles will be congruent. So, this is the actual theorem. If two lines are parallel, then corresponding angles will be congruent. Notice it was an if-then statement. This is the hypothesis of that if-then statement, that conditional, right? And this guy over here is the conclusion. Well, remember, the hypothesis is like given information. Like, here you go, man. I'm giving you something. They're basically telling me that we have parallel lines. And if we have parallel lines provided for us in the picture, then that means that any pair of corresponding angles will be congruent to each other. So when we start doing our proofs, this is what we would be expected to write down, this whole sentence in that justification step. Holy cow. Mathematicians don't like to write sentences, so we're going to abbreviate this. And we start with the hypothesis. The hypothesis, all boiled down, is about parallel lines. So the way we abbreviate that is this means parallel, and of course the word lines means lines. So parallel lines. Then leave yourself a little space here. We're going to put something in this space, but we're going to write what the conclusion would be justified. It says corresponding angles will be congruent, so we'll abbreviate corresponding, C-O-R-R, and angles, we'll do the angle symbol with an apostrophe S, and they're supposed to be congruent to each other, so remember that's the congruent symbol. It's the equal sign with the little squiggly above it. But since this was a conditional, this if-then stuff, what we need to do is put this cool arrow right here, which means an if-then statement. Now, earlier in our book, they used a single arrow, and I like to use the double arrow just to stay consistent with what I've done in the past. So that double arrow right there, and here, put yourself a little note of how that's read out loud. You say that as implies. So this is the justification that we're going to write down. And let me tell you, it's a pain in the butt if you don't know what it says. So this says parallel lines implies corresponding angles congruent. One more time. Parallel lines implies corresponding angles congruent. Now, every time you write that down, you should say it to yourself, because otherwise, if you don't say what it means, here's what kids think. They're like, oh, slash, slash, lines, funny arrow, core, symbol, squiggly thing. I mean, obviously that makes no sense if you don't know what any of this stuff means. So, parallel lines implies corresponding angles congruent. And implies is a very fancy way to just say means. Parallel lines means that all your corresponding angles will be congruent. So let's try some problems down here. What are they giving me, baby? They're giving me that A is parallel to B. Again, we're reading stuff, reading for what it means. A is parallel to B. Whoa, I got a picture. We should go to that picture and mark what that means. I got to mark these lines parallel. Remember, we do that with arrows. So I have marked what they gave me. They also said measure of angle 1 is 70 degrees. I will put that in the picture. And don't forget the little degree symbol. Just don't put a 70. Okay? Now, they want us to figure out all these other angles and justify each reason. I typed this out. This is my train of thought going here. They gave me angle 1. Look which angle I went to directly after that. I went straight to angle 3. Why in the world would I go to angle 3? Oh, because those are vertical angles. And I know that their measures have to be the same. So, 70 degrees. And the reason I knew that was because of the vertical angle theorem. And we can abbreviate just like we've done in the past chapters. That's how I knew that. Then my train of thought says, I'm going to figure out angle 2 next. And I want to figure out angle 2, I need an angle to help me. I could use angle 1 if I want to, or I could use angle 3 if I want to. It's really no big deal, but regardless of which way I do it, I should get 110 degrees because angle 1 and angle 2 are what we call a linear pair, and angle 2 and angle 3 are a linear pair, so I know that this puppy has to be 110 degrees by the linear pair theorem. Linear pair theorem says if two angles are a linear pair, then they're supplementary. Means they add to 180. So since this is 70 degrees, this has got to be 110 degrees. Then, of course, my train of thought immediately goes to angle 4 right after that because I'm using this 110 to say, oh, angle 4 is a vertical angle with that. It's also got to be 110 degrees because of the vertical angle theorem. And to be quite honest with you, you could have used 3 to help you. You could have used 1 to help you. The snowball's kind of rolling down the hill now. It's like, oh, man, I'm really getting the ball rolling. I can justify this stuff however I want. But now we get stuck because that took care of everything upstairs. And that was all review from the past. I got to get downstairs somehow and figure out all these other angles. And of course, my train of thought went to angle 5 because the angle that they really gave me something to start with was angle 1. Right? I had angle 1. I can use that to figure out angle 5 if I just know what kind of angles those are. Oh, those are corresponding angles. They are in the same position with respect to this transversal right here. So, you got to realize, though, that corresponding angles will not always be the same. You have to have something given to you first. You have to have parallel lines given to you. Oh, cool, we do have parallel lines. So, since the measure of angle 1 is 70 degrees, measure of angle 5 should also be 70 degrees, because if you have parallel lines, those corresponding angles will be congruent to each other. And that's exactly what we're going to write right here. If we have parallel lines, which we do, that means that my corresponding angles will be congruent to each other. Parallel lines implies corresponding angles congruent. So if they give you parallel lines, all your corresponding angles should be congruent to each other. So measure of angle 6 is where I go next. Now it's like free-for-all. It's just crazy. You could justify however you want. To figure out the measure of angle 6, you could use angle 5 to help you, or you could actually use angle 2 to help you, because aren't 2 and 6 corresponding angles also? I'm going to go with 5. Right, I'm going to use 5 to help me because that's the linear pair theorem, and I think that's easier to write down than this justification, linear pair theorem. Then angle 7 right here, you could use many things to help you. You could use 6 to help you. You could use 5 to help you. You could use 3 to help you. But one way or another, I think this information right here, these angles across from each other, those vertical angles, is the easiest way to justify. And then measure of angle 8, definitely 110 degrees. And you get your choice. I'm going to use angle 6 to help me with the vertical angle theorem again. The numbers should all be perfect, right? The real trick to the whole deal was how in the world did I get from upstairs to downstairs? I had to use this justification, which says parallel lines implies corresponding angles congruent. So last problem here, Last problem here. Use the picture at the right to write an equation to solve for x. And we actually will solve for x. Then justify our reason. So, whoa, use the picture. Well, let's see what we got here. I got some expressions in these angles right here, but we did a good job in class of recognizing this. What do they really give us? They give me parallel lines. It's like a hidden secret. They're telling me line M is parallel to line N just by those arrows in the picture right there. You know, they're not going to do that often. They're not going to say, hey, check it out, line M is parallel to line N. They actually have it in the picture. So you have to realize you were given parallel lines. Hey, what kind of angles are these right here? Aren't they corresponding angles? So, since I have parallel lines, shouldn't these corresponding angles be the same? So I can say 2x minus 15 will definitely equal x plus 55. And solve for x. Let's subtract x from both sides. Minus x. And get x minus 15 equals 55, because those my way. And then add 15 to both sides, and x equals 70. But don't forget, we need to justify our reason. How did I know I could set that equation up? They gave me parallel lines. And that implied that my corresponding angles will be congruent to each other. So your homework, I have an entire worksheet for you to do on paper, worksheet 3.1, but then at the end of that worksheet it says don't forget to do these 6 problems from the mid-chapter quiz, problems 15 through 20. So please, please, please let me know if you have any questions, and have a good one.